Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2016 Maths Methods Exam 1 suggested solutions. And yeah, let's smash through this paper. Like always, before I start this video, guys, if you guys want private tutoring in methods, specialist physics and chemistry, you can always email me through this, email, and we can have a discussion. With pretty much joining my Discord, course, you will get a dedicated Discord server where you will get access to thousands of past exam questions and also a Q&A section with other students where you can post hard questions that you are struggling with, and I'll be there to answer them. So if you are interested, please email me down here. So yeah, let's smash through this paper. So question 1. Let y equals cos x squared plus 2, find dy dx. Okay, so we're going to use the quotient rule here. So our u is cos x, our v is x squared plus 2. So our u dash is negative sine x, our v dash is 2x. So we can say that dy dx is negative sine x, x squared plus 2, well, that's not good to write, x squared plus 2, minus 2x cos x, all over v squared, which is s squared plus 2 squared. Done. Let f be this, evaluate f dash of 1. So we're going to use the product rule here. So u x squared v e 5x. So u dash is 2x, v dash is 5e 5x. So our f dash of x is 5e 5x x squared plus 2x e 5x. So f dash of 1 is 5e 5 plus 2e5, which is 7e5. Done. Question 2. Let f be from negative infinity to half, where f of x is this. Find f dash of x. Okay, guys, if you don't know, there's a quick way, a shortcut to find the derivative of anything that is a square root. For example, say we have a function inside a square root. Our derivative of this is the derivative of the inner function, which is f dash of x, all over 2 square root of f of x. So this notation, you should memorize this because, a lot of past exam questions, in the future, also, you'll get questions that have the square root, and you can use this quick method to do it. So you don't waste your time doing the chain rule. So yeah, so for example, for this one, okay. So we can just say f dash of x is, so the inner function is 1 minus 2x. So deriving it, it'll be negative 2 over 2 and just 1 minus 2x. So we can cancel those out, those 2's, and it'll become 1 minus 2x. Done. Find the angle theta from the positive direction of the x-axis to the tangent to the graph of f at x equals negative 1 measured in anti-clockwise direction. Okay, not too bad. So if I was just going to always draw a diagram, by the way. So let's just draw a diagram. And how does this graph look? Well, it's 1 minus 2x, the square root. So it looks like this. And it's just like that, pretty much. And so if we were drawing a tangent at x equals negative 1, say it's over here. If I was just drawing a nice tangent over here. Alright, say it like that. What's happening? Well, if you really look at this, if I was just drawing this longer actually too, it will cross, and this will be our actual theta that we want. If the one that we will calculate, it will be this theta, but we want from the positive direction to this one. So we want this over here, this angle alpha. So yeah, so let's actually just calculate that. Now you should know the formula m equals tan theta. So our m is our gradient of the tangent, so which is what? So it's just, what's f dash of negative 1? It'll be negative 1 over square root 1 minus 2 negative 1, which is negative 1 over square root 3. So then we're saying what is the inverse of tan of negative 1 over root 3? Well, if I'm not mistaken, it's pi on 6. That's your base angle. But it gives us this angle over here. That's pi on 6. So it's what's just pi, that 180 minus pi on 6. That's 5 pi on 6. That is your actual angle. It's this over here is this angle. That's what we want to calculate. So yeah, that should give you the answer, 5 pi on 6. So yeah, for these questions, always draw a diagram just for you to have a look at. Yeah, so let me just, next question. Question 3, where f of x is this. Okay, sketch the graph of f, label the axial intercepts and the coordinates, and label any asymptotes with the appropriate equations. Okay, so we know that there will be x equals asymptotes at x equals 1. So we can just draw a nice x equals 1, and also an asymptote at 2, y equals 2. What about its axis? What about its y-axis? So if I sub in 0, so 2 plus 3, 1, so it's 2, negative 3, negative 1. So it will cross this over here. And what about its x-axis? Where does it cross its x-axis? So we can say negative 2, 3, x minus 1, negative 3 on 2, x minus 1, 1, minus 3 on 2, which is just 1, minus 1.5, which is 0.5, negative 0.5. So it crosses around here. Okay, that's nicely. So if I'm just going to nicely draw like this, cross it over here, like that. Perfect. So, and I want to make sure to have they have to be equidistant. For example, this over here, they have to be equidistant. So what I'm going to do is we're going to sub in 2. What's at 2 and what's at 3? So if I subbed x equals 2, what happens? So 2 plus 3, 2 minus 1, which is just 1, so it'll be 5. So add 2 will be 5, so it'll be here. And what about 3? So 3 minus 1, which is 3 on 2, 2 plus, so we're saying 2 plus 1.5, so 3.5. So it will be around here. Okay, and yeah, so that'll be that. So this will look like that. Yeah, perfect. But yeah, it goes forever. Done. And we just have to label the asymptote. So y, so at x equals 1, y equals 2. The coordinates, so axial intercepts also. So that's half 0, negative half, sorry, negative half 0, and this over here is 0, negative 1. And label any asymptote. Okay, that's it. I hope that's good enough. Yeah. Find the area enclosed by the graph of f and the lines x equals 2 and x equals 4. So we want to find the area x equals 2, so here and here. Yeah, so we want to calculate this area over here. So we can say that's what's the area of from 2 to 4 of the function. 2 plus 3 x minus 1 dx. Is that right? All right, so let's do that. So let's split it into 2. So we can say that 2 to 4 dx plus 3 to 4, 1 x minus 1 dx. And that will be 2x 4, 2 plus 3 log e absolute value x minus 1, 4, 2. And that'll be 8 minus 4 plus 3 log e 3 minus log e, so 2, it'll be 0 pretty much. Yeah, this will be just 0. Let's cancel that out. And we can say what's 8 minus 4, it'll be 4, plus 3 log e 3. That's your area. Done. Question 4. A paddock contains 10 tagged sheep and 20 untagged sheep. 4 times each day, one sheep is selected at random from the paddock, placed in an observation area and studied, and then returned to the paddock. So it is with replacement. What is the probability that the number of tagged sheep selected on a given day is 0? Because it's returned, so it's returned. So it's with replacement. We can use binomial distribution. So we want to find the probability that the number of tagged sheep select on a given day 0. So we can say, let's say x is binomially distributed. So we know that in a day, they take 4, because 4 times in a day, so 4 times in a day. And they also, we want the probability of being a tag ship. So we know in total that there is, the probability is what? It's 10 over 30. Because in total, if you add these, it'll be 30. And only 10 are tag ships, so it's 1 on 3. So 1 on 3. And we want to find the probability that the number of tag ships selected on a given day is 0. So x equals 0. So that will give us 4 choose 0. 1 on third, 0, 2 on third, 4 minus 0, which is 4, which is just 2 on 3 to the power 4, which is 16 over 81. That's that. Nice. What is the probability that at least one tag ship is selected on a given day? So we want the probability of x is greater or equal to 1. Yeah. What is the probability that at least one tag ship is selected? So we can rewrite this as 1 minus the probability of x is less than 1, which is just, we can just say probability of x equals 0. Yeah, and we've already calculated that, so it's 1 minus 16, 81. So, how much do we add? So if we add 64, it'll be 65 over 81. Perfect. What is the probability that no tag ships are selected on each of the 6 consecutive days? So now there's 6 consecutive days, so n equals 6. Express your answer in this form where a and b are positive integers. So what is the probability that there are no tag ships? So we know that the probability of the number of tag ships selected on a given day is 0. Wait. What's the probability that no tag ships are selected on 6 consecutive days? So, what does that... Okay, so we know from A, it says, what is the probability that a number of tag ships selected on a given day is 0? So, that's the number of tag shipped when we want it to be 0. So, that means that it's the untagged. So, because this is when we're calculating the pretty much no tagged, because we wanted 0. So this probability here is for no tagged. So yeah, so if we want 6 consecutive days, we just say, what is 1681 to the power of 6? Yeah, that's that. Which, yeah. Do they want to simplify it? Nah, that's it, yeah. Is that right? Because yeah, if you look at a tree diagram, let's say if we draw a tree diagram, say we wanted no tag ships, no tag ships, no tag ship. It's just the same probability because it's with replacement. So if we wanted 6 consecutive days, yeah, we just power it to the power of 6. Yeah, is that right? 16 over 81 to the power of 6. I gotta have to double check my answers. I'm not gonna lie, maybe that's quite confusing, actually, the last one. Yeah. Question 5. If f is this, where f of x is that, and g of x is that, find the rule of h. Okay, nice. So, h of x is just, so f is log e, what's x squared plus 1. That's it. State the domain and range of h. Okay, so your domain is the same as the domain of g, the inner function, which is all reals. So your domain of h is all reals, and your range of h is what? Well, we know the equation. So if I was just going to draw a nice graph of the actual thing. So let's say x equals 0. What's happening to the graph? So at x equals 0, it's actually 0. What about 1? It'll be over here. 2. It increases, increase. Okay. What about if we put -1? It always squares. So again, it looks like pretty much a parabola. Okay, that's good. So our range would be from the least, which is 0, and that's going to be included to infinity. Is that right? Yeah, 0 to infinity. Show that h of x plus h minus x is this. Okay, so let's just say that your left-hand side, so we want h of x, which is log e x squared plus 1 plus log e, because it's just being squared, it's just going to be again x squared plus 1, which is just 2 log e x squared plus 1, which is just the same as log e x squared plus 1 all squared. Yeah. And then we can say that right hand side is f, which is what? Log e x squared plus 1 all squared. Oh, not all squared. Yes, squared. And we can say then your left hand side actually does equal your right hand side. So yeah, that's a good way to prove. Find the coordinates of the stationary point of H and state its nature. H. Okay, so we know H is there. Now, okay, you guys should know also how to do the derivative of logs. Whenever you see a log, for example, let's say a log with a function inside, let's say f of x, the derivative of the whole thing is what? It's just the inner function, f of it dash of x over f of x. That's it. This is the actual rule. So, for this one, it's nice and easy. So, what's the inner function? It's x squared plus 1. So what's the derivative? It's just 2x. So we can say 2x over x squared plus 1 is actually equal to your h dash of x, by the way. So we want the coordinates of a stationary point. So we want h dash of x to actually equal 0. So what's 2x x squared plus 1 equals 0? What's 2x equals 0? X must therefore equal 0. That's a stationary point. So if we sub in what's h of 0, 0, it's actually 0. So your coordinate is 0, 0. What about its nature? There's many ways you can actually find its nature. And let me tell you a quick way that I use. A way that I use is using the double derivative. It's a quick way. And how? For example, so we already calculated h dash of x. What about if we just calculate h dash dash of x? Now we're just going to have to use what we call is the quotient rule. So let's use the quotient rule quickly. So that's u and that's v. So we can say x squared plus 1, 2, actually put that there, minus 2x all over x squared plus 1 all squared. Now, because we know that the value of x at which the stationary point occurs, let's sub that in. So what's h dash of 0? It'll be 2 over 1, so 2. Okay, if your double derivative is greater than 0, like a positive number, it means a minimum occurs, a minimum, local minimum. If it was a negative, like say -2, it occurs a maximum. If it's equal 0, then that's a stationary point of inflection. But here it's a positive value, meaning that it's a minimum value. So we can say that the coordinate 0, 0 is actually a local minimum. Yeah, or you can do another way, like the actual basic way, which is the nice and, for example, you just draw, the nice and, for example, we know at 0, and let's say that's -1, that's 1, and we know what occurs. So at 0, it's a straight line, and we sub in 1, what's its gradient? 1, 1, it's a positive, so up, the other one should be negative also, so it looks like a minimum too. That's the actual methods way. It's good to know both ways. A lot of ways to actually, calculate. Let k be -infinity to 0, where k is this. Find the rule for k inverse. Okay, so we want to first say, let k of x equal y, and interchange y and x. So we can say x equals log e y squared plus 1. So ex y squared plus 1, ex minus 1 plus 1 negative square root of y. Now, because we know it's in the negative part, because negative infinity is 0, we just take the negative, so negative ex minus 1, and that's going to be our inverse, or which is k inverse of x. That's your rule. Yeah. So our final k of x is negative square root ex minus 1. Yeah, am I doing something wrong? Perfect, yeah. State the domain and range of k. So your domain, you should know that your domain is your range of the original function. For example, if you look at here, let me just write domain and range, actually. So first let's calculate our range, because our range is just our domain, and we're given our domain, luckily. So it's from negative infinity, 0 included, is it? Yeah. And what about our domain? Well, okay, it's very easy. We'll just, it's the range of the original function, this. Let's calculate the range of this. So 0, it's the same as what we've done. It's like, it looks like this. It looks like an actual parabola. So our range is from 0 to infinity. So 0 included to infinity. Done. Next question. Question 6. Okay, let f be where f of x is this. Find the average rate of change between this and that. Okay, so that will be f pi on 6 minus f negative pi on 3 all over pi over 6 minus pi on 3, which is, pi over 6 minus pi on 3, so it's just pi on 2. Done. So what's f pi on 6? So it's just 2 sine pi 3 minus 1 minus 2 sine negative 2 pi on 3 minus 1 all over pi on 2. Now, this will simplify to, what's sine pi on 3? Well, we know that's root 3 on 2 minus 1 minus. Okay, so we can take that negative to here, so that becomes a positive here. So what's pi on 3 pi minus? So that's pi minus, so it'll be over here, CAS. So this can be just simplified to, this whole thing can be just simplified to like 2 sine pi on 3. So yeah, we can pretty much simplify this to pi on 3. Okay, so we're saying what's negative 2 times root 3 on 2. Yeah, so minus 1 all over pi over 2. So that'll be root 3 minus 1 minus root 3 minus 1 all over pi over 2. So that'll be root 3 minus 1 plus root 3 plus 1 all over pi over 2. So that'll be 2 root 3 times 2 over pi, which is 4 root 3 over pi. So that's your answer. Calculate the average value of f over the interval this. So okay, so our average value is 1 over pi over 6 minus negative pi on 3, which is just, pi on 2. And just with the reciprocal of pi on 2, it's just 2 over pi. Integral from negative pi on 3 pi on 6 of the function 2 sine 2x minus 1 dx. So that will be 2 over pi. Okay. 2 times 1 over half. So it'll be negative cos 2x minus x pi on 6 negative pi on 3. We're nearly done, so that'll be equal 2 over pi. Okay, so it'll be negative cos pi on 3 minus pi on 6 minus negative cos. That negative disappears, so it'll be just 2 pi on 3 minus, so plus pi on 3. We're nearly done, so that will be 2 over pi. Negative half minus pi on 6 minus, okay, this over here becomes cos pi on 3 plus pi on 3. 2 pi negative half minus pi on 6 minus half minus pi on 3. What? Wow, it's just so long. Negative pi, negative 1, minus pi on 2 will be negative 2 over pi minus 1. Negative 1 minus 2 over pi. Is that right? Oh, I don't know. Wow, that's 3 marks. Dang, that's a lot of algebra. Maybe I made a mistake somewhere. Let's have a look. Just have a look. Damn. It doesn't look bad. Okay. Question 7. A company produces motors for refrigerators. There are 2 assembly lines, line A, line B. 5% of the motors assembled on line A are faulty, and 8% of the motors assembled on line B are faulty. In 1 hour, 40 motors are produced from line A and 50 motors are produced from line B. At the end of the hour, 1 motor is selected at random from all the motors and have been produced during that hour. What is the probability that a selected motor is faulty? Express yourself in this form. Okay, this is nice. So you should know straight away to draw a tree diagram for this, because it just tells us that the line A, like for example, line A, line B, and there's faulty, non-faulty, faulty, non-faulty. Now we know that the probability of being a faulty in line A is what? 5 over 100, and the other one would be 8 over 100. And we also know that 40% are produced from line A, so like 40 out of 9, so it'll be 4 on 9, that'll be 5 on 9. So if we want to calculate the probability that it's faulty, it's going to be 4 on 9 times 5 over 100 plus 5 on 9 times 8 over 100. So this, this over here becomes 25, becomes 5. So what's 1 over 9, 5 plus, again, this one becomes 20 here, and this over here, I'm at half, so let's say 4, and this becomes 10, halves again, 5, plus 2, plus 2 over 9, 5, so adding them both up, it'll be 3 over 9, 5, this here will become 3, so it'll be 1 over 15, yeah. 1 over 15, and it's in the form as 1 over b, where b is a positive integer. Done. If the selected motor is found to be faulty, what is the probability that it was assembled on line? Okay, now this is a word. This is where they're trying to trick you. It is conditional here. They've given you a hint. They say the selected motor is found to be faulty. What is the probability that it was assembled on A? Think of it like this. Written like this. What is the probability that it was assembled on line A, given that the selected motor is found to be faulty? That's why it's like, it's just written as, and this kind of did trick a lot of people, and I think it will. So this is what we're saying. So what's the probability that it's assembled on line A, given it's faulty? So we want the probability of A intersection F over the probability of F. So A intersection F is easy, because we've seen that's just 1 over 9 over 5. From this, yeah. Yep. And we're dividing it by probability of faulty, which is just 1 over 15. So it's just, what's 1 over 9 over 5 times 15. This cancels out to 3 times, and this over here cancels out 3 times, so it'll become 1 on 3. Yeah, 1 on 6. It's in that form too. Question 8. Let x be a continuous random variable of the probability density function this. Okay. Part of the graph of f is shown below. The graph has a turning point at x equals 1 on this. Okay. Show by differentiation that this over here is an antiderivative of this. So, okay, so we just need to calculate ddx of the derivative of kx over k squared, k log e, x, and we want to come to this equation when we derive it. So I'm just going to use the product rule, because it's 2 things being multiplied. So it'll be xk over k squared times, now what's the derivative of the inside? It'll be just k over x plus k log ex minus 1. The derivative of this is what? Well, it's just that constant. We can take it out, and so, like, what's the derivative of k, this over here? It's just, if we bring that k, it'll be k over k squared, x k minus 1. It's just 1 over k, x k minus 1. So we can say 1 over, 1 over k, x k minus 1. Done. We are nearly done. Okay, hopefully. So, simplifying this, we can cancel those k's out. Okay, and by the way, these two are the same. So, what's k minus 1? It's just x k minus 1 over k. Plus, multiplying this by expanding, so it'll be x k minus 1 log ex minus 1 over k x k minus 1. And these two cancel out, like these two cancel out pretty much. So it's just leaves us with x k minus 1 log e x. Yeah, and that's probably, yeah, that's that. Calculate the probability that x is greater than 1 over e. So yeah, okay, so 1 over e. So we want to calculate the integral. 1 over e to 1. Was that right? Max, yeah. So 1 to 1 of the function. Negative 4x. Let's just take that negative 4 out at least. So negative 4, what's x log ex dx? That's what we want to calculate. Now we can't actually integrate log because that's not part of our study design, but luckily we're going to use integration by recognition here. Look at this. Okay, have a look at this. So we've calculated the ddx of xk over k squared k log e x minus 1. And that results in xk minus 1 log ex. What about if I said, if I wanted this to be the same as this expression, what should we let k equal? We will let k equal 2. Because what happens now? Well, it will just become ddx x2, 2 squared 4, 2 log e x minus 1, x log e x. Perfect. So if I was going to integrate this side here, ddx, I have to integrate both sides this one. Luckily, these cancel out. So this is the actual antiderivative of it. So yeah, so now we can just say what's equals negative 4 of x squared over 4, 2 log e, x minus 1. Yeah, so that all from 1 to 1 over e. So that will be what? So it'll be negative 4. Alright, so if I sub them, well, actually, let me just rub that out. If I bring that 4 in, it just becomes easier for me. Negative x squared. Yeah? Yeah, if I bring that thing, it'll be negative x squared. 2 log e x minus 1 from 1 to 1 over e. So let's do that. So that'll be negative 1, 2 log, that'll be 0 if you sub in 1. So you can say that the inside is 0 anyway. Minus 1. Alright, so minus negative 1 e squared 2 log, we can say that's e minus 1. So it'll become negative here. And yeah, it'll just cancel out. So we can cancel that out. Minus 1. All of that. So that'll be 1 minus negative 1 over e squared negative 3, 1 minus 3e squared. Yeah, that's that. Done. Last question. Damn, this exam is so... Damn, I've never been... This exam's such a headache. Alright, nearly done. Okay, let's do the last question. Hence. So hence is using this over here to answer this question. Hence explain whether the median of x is greater or less than 1 over e, given that e is greater than 5 over 2. So they're saying is the median here or less than this? So the value of m, which is the median. The way that I would actually calculate that is by... Well, we know that the probability... Because it says hence, so we know that the probability that x is greater than 1 over e is equal to 1 minus 3e squared. And let's solve for e, actually. Let's solve for e. So, it will give us 1 minus probability of x is greater than 1 over e, 3 over e squared. Yeah. And that will give us 3 over 1 minus probability of x is greater than 1 over e for e squared. Now, I'm going to make my life easier, I'll be honest. Okay, I'm not going to find the square root of... Okay, so we know that e is greater than 5 over 2. So if we square it, it'll be 25 over 4. So at least we can say, given that e squared is greater than 25 over 2, and we know that e squared is equal to this, we can equate them. So we can say that 3 over 1 minus probability of x is greater than 1 over e is greater than 25 over 4. Nearly done. So, using this here, cross multiply, will be 12 is greater than 25 minus 25 probability of x is greater than 1 over e, and I'm going to calculate for probability x is greater than 1 over e. So, it'll be negative 13, if I bring that here, greater than negative 25 probability of x is greater than 1 over e. If I divide by negative, it'll become 13 over 25, but the sign changes, it'll be less than probability of x is greater than 1 over e. And if this becomes probability of x is greater than 1 over e is greater than 13 over 25. Okay, so is this like greater than a half or equal or less than a half? Let's check it. Well, what's half of 25? It's 12.5. So if this was 12.5 out of 25, it will be a half. But it's greater. So it means our value of m would be around here. So it's greater than 1 over e. So we can say median is greater than 1 over e. Done. Yeah, I'm not going to lie, guys. I just wanted to smash this exam out. It's a pain, I'm not going to lie. Yeah, I didn't find it too nice, I'm not going to lie. Algebra was a pain, I'm not going to lie. But yeah, hope you guys enjoyed this video and learned something. And yeah, take care of yourselves. Bye-bye.